of computations for 6 nodes of Tesla 870 was equal to about 2,000 node IBM Blue Gene L. So that was pretty impressive to us, and that's what this customer decided to go for. A couple of slides illustrating what our customer talked about this. Kodak was very interesting to us because that was an actual first sale of a cluster that we have produced. And what was interesting is that that allowed them to cut the development of image sensor from months to few days and hours in some cases. So that was really a real success story. Likewise, LG, another marquee cell phone customer, used to spend hours on days on designing and simulating those cell phones. And those now take just 10 minutes per simulation, 10, 15 minutes per simulation. And with the new hardware from NVIDIA, it's going to be even shorter. So in conclusions, we are probably the longest standing company that has been working on computational GPU. And we are pretty good at multi-core parallel processing and both porting and developing algorithms and understanding how those algorithms needs to be done. We have a large Fortune 500 customer base, and we really base our products on our vertical expertise and relations that we have with some of our customers. And our customers not only use this technique to accelerate the way they do things, but it actually allows them to shift the way they do things. Thank you very much. Right.
Yeah. So what kind of relationship do you have with customers?
Well, that maybe is no longer such an important point, because in the past, people didn't know what to expect. These days, there's enough examples in the marketplace that people expect acceleration anywhere from 5 times to 100 times. And depends on the industry what it really is that is important to a customer. You know, if you are running in oil and gas and your application runs for half a year, even if you could cut it by a factor of 2, that's already good, and that's actually great. Even if you can't necessarily accelerate, but use much less hardware, and then pack more hardware into your server room, that's another good thing. So really, it's an interaction with the customer and understanding what's the need, and then trying to determine whether we can meet this need or not. In most cases, 5 to 10 times is what makes people already happy.
Just a question, like in the market, like you were describing with the antenna, are you selling a kind of simulator you plug into MATLAB or some existing tool that accelerates the calculation?
Right. No, we are actually partnering with independent software developers, people who have this software already. We're not competing with them. We're trying to help them gain larger market share by making things faster. So we don't deal with user. We would, if think of it this way, we are building the engine for those guys. So they have graphic user interface and they have customer relations and everything else. We just take the engine that they used to have and put a new engine that is way, way more powerful. That's what we do. Right.
Or are you using, which are really not parallelizing very well?
Right.
Or are you using relaxation methods?
Well, none. None, actually. So neither of the. So we are mostly working on iterative methods, but not so much on relaxation type, although we use relaxation also in the sort of nitty-gritty of what we're doing. We base this all on Krylov space methods. And then we based it also on things like algebraic multigrid and ILU preconditioners, which is the key to actually solve those very, very large problems. Now, Even those, like ALU, for example, tend to be, at least on the surface, fairly sequential. So inside those solvers, we try to rework them such that those sequential bottlenecks are replaced with parallel equivalent. So in general, those parallel equivalent would take more operations, but since you can make them parallel, you gain. So what's your follow-up question?
Well, basically, for instance, if you use relaxation methods, then the solution changes slightly from, whatever you had with, the regular mathematics.
Mm-hmm.
Right? And usually what happens is, your model is just an approximation of reality.
Yeah.
So for instance, if somebody does crash analysis,
Right.
has been using, sort of the traditional math methods for that,
Right.
They're sort of used to know exactly where the model deviates from reality.
Right.
If you give them something where the math changes,
Right.
so they usually have to have years to get adjusted again to what those differences are to, what they
Yeah.
discovered earlier.
You're absolutely right. And that's why for very large sparse system, it's so difficult to actually create a library and just give it to people and have them play with it. In fact, it's just the opposite. The engagements that we have with customers that actually have those needs, it's an adoption of our library. So we have a base library, but then we work with those people, trying to understand exactly the things that you're talking about and finding the best paths through our libraries or developing additional add-ons to those libraries to make sure that all the cases that they have still converge in the right way. It's a very important point.
Last questions?
Okay, thank you very much.